This is Chapter 5, Lesson 4, Compare and Order Rational Numbers. Okay. So we have a couple of diamonds. So the first diamond says blank, blank, a common multiple of the denominators of two or more fractions. So in those two blanks, you're going to write common denominator. So common denominator is a common multiple of the denominators of two or more fractions. Okay. In the next diamond, it says blank, 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 the least common multiple of the denominators. In those blanks, you're going to write least common denominator, LCD. Okay, so least common denominator, LCD, so least common multiple of the denominators. Okay. In the last diamond, blank, blank, a number that can be expressed as a ratio of two integers written as a fraction, where the denominator is not 0. In those two blanks, you're going to write rational number. Okay. So I have a couple of examples. So the first example says fill in the circle with less than, greater than, or equal to make negative 5/6 and negative 1 1/6 a true statement. So what I can do is I can actually graph each rational number on a number line, mark off equal size increments of 1/6 between negative 2 and negative 1 because they're both 1/6. They both have 6's in the denominator. Okay. So here's negative 1 5/6. And here is negative 1 1/6. So you're looking to see which one is bigger. Okay, and because they're both negative, you want to see which one of these is closer to 0. That actually is the bigger one. So 0 is this way on the number line. So the one that's closest to 0 is negative 1 1/6, so that's the bigger number. So the number line shows that negative 1 5/6 is less than negative 1 1/6. Okay. Then I have fill in the circle with less than, greater than, or equal to make 7/12 and 8/18 a true sentence. Okay. So the LCD, or least common denominator, of the denominators 12 and 18 is 36. Okay. So in order to get 12 to be 36, I had to multiply by 3. Whatever I do to the denominator, I have to do to the numerator. So 7 times 3 is 21 over 36. 18 I had to multiply by 2 to get 36. So 8 times 2 gives me 16. 21 is bigger than 16. So 7/12 is greater than 8/18. In Mr. Hong's class, 20% of students own roller shoes. In Mrs. Trevino's class, 5 out of 29 students own roller shoes. In which class does a greater fraction of students own roller shoes? Okay, so I can express each number as a decimal and then compare. So 20% I can write as 0.2. 5/29 I can divide. 5 divided by 29 is 0.1724. So 0.2 is bigger than 0.1724. So that means 20% is greater than 5/29. The next thing I want to do is order the set 3.44, pi, 3.14, and 3.4 repeating from least to greatest. Okay, So I'm going to line up the decimal points and compare using place value. So this was originally 3.44. This was pi. This is 3.14. And this was my 3.4 repeating. Okay. I can take it out to as many digits as I want to. I recommend, since pi is an irrational number, taking it out to at least 3, because that seems to be all the other ones with terminating decimals end at 2. So taking it out 1 extra place value is helpful. Okay. So in that case, 3.44 becomes 3.440. I'm going to annex some zeros. Okay. This will allow me to make sure that they're all lined up and they have the same amount of place values. Okay? So then I can look down and say, so the order of the numbers from smallest to biggest is 3.14, then pi, then 3.44, and then 3.4 repeated. So there are a couple of try it problems. I want you to go ahead, pause the video, try them out, and when you're done, we will go over the answers together. All right, now that you've tried the try it problems, let's go over the answers together. So the first try it problem says fill in the circle with greater than, less than, or equal to make -5 and 5/9 and -5 and 1/9 a true sentence. So I'm going to look at this. Okay. So I'm actually going to look at this problem and try to figure out which one is closer to 0. So if I look at it, -5 and -5 are the same. So 5/9 and 1/9. 1/9 is closer to 0. So that means -5 and 1/9 is less than -5. Oops, sorry. -5 and 5/9 is less than -5 and 1/9. Okay. Problem number 2 says fill in the circle with less than, greater than, or equal to make 5, 6, 7/9 a true sentence. Okay. So I need to come up with a common denominator. A common denominator is 18. Okay. In order to do this, I had to multiply by 3 for the 5, 6, so I get 15/18. And for 7/9, I had to multiply by 2, so I get 14/18. 15 is bigger than 14, so 5, 6 is greater than 14/18 or 7/9. Bigger than 7/9. Okay. Example number 3 says in a second period class, 37.5% of students like to bowl. In a fifth period class, 12 out of 29 students like to bowl. In which class does a greater fraction of students like to bowl? So 37.5%, I can write as a decimal, so 0.375. 12 29ths I can divide, so 12 divided by 29. I get 0.414. Okay, so I rounded. 0.414 is bigger than 0.375, which means (37.5%) is less than 12/29. So the fifth period class had the greater percentage, greater fraction of students who like to bowl. The last problem I have on this page is order the set 23%, 0.21, 1/4, and 1/5. So 23% becomes 0.23. 0.21 stays the same. 1/4 is 0.25. And 1/5 is 0.20. Okay. I'm ordering from least to greatest, so smallest to biggest. The smallest one is 1/5, and then it's 0.21, and then it's 0.23, and then it's 0.25. Okay. So my smallest is 1/5 is less than 0.21 is less than 23%, which is less than 1/4. Okay. On page 69, you have an ice cream cone. Okay. Using the definitions that you have on page 68, I want you to put in the number sprinkles on the lines that correspond with the lines on your ice cream cone. So this ice cream cone is the real number system. Okay. So I want you to go ahead, pause the video, and then when you are done, we will go over the answers together. Okay. So now that you're done, we're going to go over the answers together. So we're going to start with your natural numbers. Okay, natural numbers are any counting numbers, okay, that don't include 0. So if I go through natural numbers, my number sprinkles, I have 1, 2, and 3. I also have 10. Okay, so those are my natural numbers. Okay, my whole numbers, I add in 0. So they're all my natural numbers plus my whole numbers. So I have 0, 1, 2, 3, and 10. Okay, my integers are all my whole numbers plus any negative numbers that are whole numbers. So I have 0, 1, 2, 3, and 10. I also have -1, -2, and -3. Okay. Then I have rational numbers. So rational numbers are anything that can be written as a decimal, a terminating decimal, or as a fraction. So that includes all my integers, and any of the numbers that can be written as a fraction. So I have 1.5, 3/4, 0.009, 5/6, 1.76, 3/2, P over Q, 3.14, square root of 100, which turns into 10 actually, and -2/17. Okay. So that means I'm left with irrational numbers, which is my cherry on top. My irrational numbers are pi. Okay. And that is your, and that's the end of lesson 4.